I'm Mr. Richmond. This is your Integrated Math 1, Unit 7.1 Lesson Summary. In Unit 7.1, we'll be focusing on graphing inequalities, linear inequalities, in a coordinate plane. We have solved one variable inequalities and graphed them on a single number line. That's when you graph things like x less than 3. You move over to the 3, you put an open or a closed dot, shade left or right. Well, now that we have two variables, we have to graph on a full coordinate plane, a two-line, number line coordinate plane. So to do that, I actually graph it just like I would graph a normal equation, linear equation. So I like to pretend it's just y equals the start to get my line. Now, if something is a less than or greater than symbol, it will create a dashed line because this is a line full of open dots, just like how we had an open dot when we did those type of inequalities. But since drawing a ton of open dots would be kind of difficult and time consuming, we do a dashed line instead. If the inequality symbol has a line underneath it, that means it's less than or equal to or greater than or equal to, well then it's a bunch of closed dots, which we just express with a normal line like we have previously. So again, the steps to graph these, I'd first identify what graphing method you're going to use, graph a line, make it solid or dashed, and then we have to shade in the area that represents the solutions, just like we had to shade in the number line. Since it's an entire plane now, what it does when we draw a linear inequality is it splits it into two different planes, what we call half planes. I'm going to shade one of those because one of those will represent the solution. So for this one, it's in slope-intercept form. I really can pretend it's y equals negative 2x plus 6. And since that's in slope-intercept form, I would notice the slope is negative 2 and the y-intercept b is 6. And I'd plot those. A slope of negative 2 means down 2, right 1 from the y-intercept given here by 6. So that'd be 0, 6. So I'm going to plot that now. Y-intercept of 6 goes up 1, 2, 3, 4, 5, and 6. Put my first point, and then move from that point, my starting point, by my slope, down 2, right 1. Down 2, right 1. Down 2, right 1. Until I get my line. Now, at this point, this is where probably the number one mistake comes from graphing inequalities, is forgetting to make it dashed if it's supposed to be dashed. So always take a second, pause, double check your inequality sign, and then make your line correctly. So it should be a dashed line. I'm going to extend it, and it does have arrows because it is linear. It goes on forever in both directions. Now there's two ways to find out where you should shade. One is to check a coordinate. Any coordinate I check that's in the shaded region should keep this inequality true when I plug it in, because this graph is going to represent all the different possibilities here for answers. So as long as I check a point on each side to see if it works, the one that is the point that's on the side that is going to work for the solution is the side I should shade. So I'm going to plug in a 0, 0, since that's one of the easiest points. Can't always use that point depending on where the line goes through, but usually if it's not on the line, I will check that point. So I'm going to plug in 0, 0. 0 is less than negative 2 times 0 plus 6. So 0 is less than 6. That is true. So that tells me that the shaded region should be the region in which 0, 0 is on. And obviously I can't shade the whole thing forever because it goes on forever. So I just shade the majority of the side of my coordinate plane that I have drawn. And to prove to you that this is correct, I'm going to show another point here. So let's go negative 1, negative 2, negative 3, negative 4, comma 2. That is in the shaded region and therefore should work for the inequality. Let's try it. Y was 2 less than, x was negative 4 plus 6, and negative 2 times 4 is 8, 8 plus 6 is 14, and 2 is less than 14. So you can see that any point that I'm choosing in this zone is a solution. And that lets the reader see all the different possibilities that work, since I can't name them all individually. Another way to tell when they're in slope-intercept form like this, where to shade is by reading the first part of it. As long as y is positive, you can do this shortcut. But it says y is less than, and less than would usually be lower numbers, so it would be below. So I shade below that line. Okay, so I can speed it up sometimes. All right, let's try a word problem with this, just so you can see some of the applications of graphing linear inequalities. So our next situation says you can buy shirts for $5 and pants for $7 at the outlet. So maybe there's a sale going on, that's the price you can get, you're seeing what you can buy. It says you can spend no more than $70, which would mean I can spend $70 exactly or anything less than that, and that'd still be okay. I'd have money to take home. How many shirts and pants can you buy? Show your answer graphically. Well, if I asked you that, you'd probably go, well, I could buy 10 pants. That goes in 10 times. I'd spend all my money. If there's no tax, obviously, for this example. And 5 times 12 is 60. I could buy, looks like 14 maybe, shirts. So yeah, but what combination? How many, what if I only bought a few pants and a few shorts? So there's a really large number of possibilities here. That's why we show this graphically, because you're just showing the reader all the different choices you have. So to do this, we first need to define our variables. And since we're graphing it, I'm going to try to keep them simple, keep them x and y, so that we have one we can put on each coordinate plane. So our x can be shirts, because that's one thing we're finding. And again, I always find the variables by reading the last sentence. It tells me what they have to be. I have shirts and pants, so that needs to be my variables. So I'm going to go x is shirts, y is pants, and of course I'm going to label my axes shirts and pants. Now, in order to graph this, I need to have something to graph. So I'm going to try to write an inequality to represent this using 2 variables. So it's about money I'm spending, and I can buy shirts for $5 each. So that would be 5x, similar to the ones we've written before. And I can also buy pants for 7. So just to make sure that works, if I bought 1 of each, it'd be 5 plus 7, which works. If I bought 2 of each, it'd be 10 plus 14, which is 24, which would also work. And I want this amount that I'm spending to be less than or equal to $70. So usually, a lot of times when you write these linear inequalities, you can see whenever there's 2 variables, it can be in standard form. So that means we also need to know how to graph inequalities in standard form, not just slope-intercept. So let's give this a try. Remember, one of the easiest ways to graph inequalities or equations in standard form was the cover-up method to find the x and y intercepts. So I'm going to do that for this. Okay? X-intercept, y-intercept. So let's find the x-intercept first. To find the x-intercept, I cover up the y and I solve. So I'd have 5x, and again, I can pretend it's equal when I'm solving or graphing or anything like that, just like I did here, momentarily. So I get 5x equals 70. Well, I know 5 times 10 is 50, 5 times 12 would be 60, another 2 would be another 10 would be 14. So my x-intercept must be 14. So I'm going to write 14 comma 0, and that'll be the first point on my graph. So I need to make it go out to 14. 1, 2. Okay, so I have my shirts labeled on the axes. Because my x-intercept was 14, 0. And you'll notice that I only use this quadrant because I don't need negatives. I'm not going to buy negative amounts of t-shirts. So usually with word problems you end up with that one quadrant plan, so that's all I need to show. Y-intercept, to find the y-intercept I cover up the x, I plug in 0 for it, giving me 7y equals 70. Divide by 7, y is 10, making my y-intercept 0, 10. Plot that. And just like that, I have my line. Connect my x and y intercepts straight as I can, and read my inequality sign. Y is positive, so I can shade below using my trick. If y was negative, I would not be able to do that. I'd have to reverse it, or just check a point. 0, 0 is technically a point. 0 plus 0 is less than 70, so this is my correct graph. And this shows the reader all the possible solutions to this system. I could go 0 and 0. I could go 1 and 1, I could go 2 and 2, I could go 3 and 3. Any point in this zone is potentially a solution. Now anything below it wouldn't be using all the money. Any point directly on that line would use all the money. And so you can see how graphing a linear inequality is useful, especially with situations where you have more than one option. It's a way to display all the options to the reader. So hopefully this helps you out. Thank you. Good luck.